uh, that Aaron Browning is going to present on. Um, Aaron is our regional sales manager from the West Coast and is considered our outdoor breaker specialist. So she'll have some information here for you that hopefully is going to be very educational. During the meeting or during the presentation, if you have any questions about the breaker or what she's presenting on, if you don't mind, just put that in the chat and we'll answer those questions as time allows us at the end of the presentation. Also, you should be receiving a link um, to our um, site that we will be recording these sessions and seminars as we go through that you can use on a daily basis or even share. So if there's no further stuff, I will turn it over to you, Aaron.
Thanks, Jason. Hey, good afternoon, everybody. I know most of you at this point from over the years, but for those of you who don't know me, as Jason said, my name's Aaron Browning. I'm the regional sales manager in the West. I'm based in Denver. I'm from the Lake Mary area originally, and in my prior life worked for ABB, supporting medium voltage outdoor apparatus, including circuit breakers, much like the OD3Mag breaker that we're selling at JST. So Jason alluded to that I'm the breaker specialist. What I think he means is I have a lot of experience selling medium voltage outdoor breakers. I have a lot of competitor knowledge about what the marketplace looks like. So if at any point in time you guys are running into challenges approaching your customers or getting conversations going with your customers, whether it's engineering or purchasing or management, I can help you navigate those different roles at your customer accounts and help you craft the appropriate messages to approach those different people. At any point in time, feel free to reach out to me regarding your outdoor breaker opportunities, and I'm happy to help. Jason also mentioned the rep training portal that was recently created. Robin Ellerick, who's on our call, she's taken a lot of initiative to set up a web-based portal for our partners. If you click on it, you guys are going to get these slides at the end. But if you click on it, you're going to be redirected to a SharePoint drive. And it's not working when I click on it. Here we go. This is what you'll see when you click on the rep portal. You'll see the different training seminars, and you'll have access to the presentations for your records. Anytime you can revert back to them to brush up on your knowledge and fact checking of our different products. So excited to have that tool available for you guys. Before we dive into the outdoor breaker, just a quick overview and recap of JST as a company and our global footprint. You guys are probably familiar with this. I think we have some new people on the call, so I wanted to show this. But over in the Western Hemisphere, we have the Nogales, Mexico facility and the Lake Mary, Florida facility just outside of Orlando. These are our North America manufacturing hubs. Most of our team is located in Lake Mary, just outside of Orlando, and this is where we manufacture switchgear and outdoor breakers. And as far as our product portfolio goes, we're going to be doing training sessions on all of these different products over the next couple of months. So I encourage you please to attend them and check out our website, because we've made some updates to the website recently with new literature and new ratings, as some of our products have expanded on ratings. So please make a habit of regularly checking the website so you know what we're doing at JST, and then of course work with your RSMs to hone in on any specific product details. But today we're focusing on the outdoor breaker, and that's what you see here on the right center. And the outdoor breaker, we launched this product in 2023 in, I guess it was February, Distributech time period. It's a new product to market, about a year and a half in the making. We have some pioneer customers. I have a list of those at the end of the presentation in case you're wondering for some customer references. But just to recap on why are we in this market space to begin with, right? So based on the published statistics, the outdoor breaker market is very large. About 9,000 outdoor breakers sell each year in the United States. That's about $216 million annually. That's a big piece of revenue. And then when we look a little bit further down the line, reclosers, about 20,000 medium voltage reclosers are sold every year. And that's a distribution pole product primarily, but we do see reclosers in the substation on occasion, especially in rural areas, smaller cooperatives, especially out west, with smaller interruption, smaller short circuit capacity, and smaller continuous current requirements. But combined, the outdoor breaker and the recloser market are substantial. And there's really not that many players on the outdoor breaker side. ABB and Siemens definitely are the market leaders. And then Eaton and MEPI come in second and third. But the ABB and Siemens, our product is comparable in certain ways, and there's other ways where we're different. We see a lot of spec influence on the Siemens and ABB side, with utilities when it comes to like arc resistant requirements or spring mechanism requirements. So today I'm hoping to cover some of these things on why we decided to build the breaker that we did and how to combat some of these challenges with the specs. So traditional outdoor breakers, and again, we're talking 15 kV to 38 kV substation class outdoor freestanding circuit breakers. Traditionally, these breakers have been three-phase operation only for as long as they've been around. And that's probably because of the design approach for the operating mechanism, taking into account some size constraints, what was realistic when pen and paper first created a circuit breaker. It resulted in a single operating mech driving three poles simultaneously, and as a result, you get three-phase operation breaker. As circuit breaker technology evolved, we've gone from like oil circuit breakers to air insulated vacuum circuit breakers, and then the operating mechanism has again historically been spring energy, where you have a device that has a series of levers and switches and motors that compress springs to store energy, and then once released, that stored energy spring has the force required to open and close a circuit breaker very, very quickly. These types of mechanisms have a lot of parts associated with them. They require regular maintenance, lubrication, and timing adjustments, because over time the springs lose their K force. So the breaker will operate a little bit slower over the course of its lifespan. So there's different requirements to keep that breaker functioning as a 3-cycle or a 5-cycle breaker, depending on how it was designed. But that's what our customers are familiar with, and that's what maintenance crews prefer because it keeps them employed. We find it keeps their budget full, so that they have jobs to do and they can rack up overtime with servicing circuit breakers. But that's the reality of the landscape with circuit breakers today. We're in 2024, almost 25 years ago, we saw an introduction in a new operating philosophy, and that's with magnetic actuators. We saw that first with ABB. Siemens later jumped on board with that around 2012 timeframe. Here in 2024, JST has a magnetically actuated circuit breaker with slight differences. So one of the ideas that we employed is a single phase breaker, so that we have the operating effects of a recloser in a circuit breaker body. So we have a substation device with circuit breaker duty in terms of continuous current rating and interruption rating, but it has the ability to do single phase trip, single phase close, so that we have the effects of and the benefits of reclosing on momentary and permanent faults. I'll get into more detail on that shortly. We've also seen improvements in the interruption device and the pole itself. So here we're talking about vacuum interrupters, and how that vacuum interrupter is installed and mounted. Embedded vacuum interrupters have proven to have a lot of benefits from a dielectric standpoint, especially in really high contaminant environments. Think a lot of dust, for example. You don't end up with dust and particulates all over exposed components of the vacuum interrupter endpoints. So an embedded pole combined with a magnetic actuator that has very few moving parts requires virtually no maintenance throughout the course of its life because it is fully self-contained, and something that is independent of environmental factors. So it has consistent operating speed over the life of the breaker and across all temperature ratings of the breaker. There's no springs that slow down over time. You don't get any sag, in other words, as the breaker reaches, 10,000 operations. And whether it's really cold outside or really hot outside, there's no springs that are going to be subjected to those temperature swings. So really, this actuator is operating off of a digital input into a controller and a rapid application of voltage from a capacitor that is independent of temperatures. So we tested this breaker to high and low temperatures and have found that the operating speed changes, I think within microseconds, actually, very, very unaffected by temperature swings. I wanted to put right here on this slide just a summary of the main ratings and talking points of the breaker, because again, you guys are going to have this, and if there's one slide that you're going to walk away or refer to in the future before you go into your customer meetings, it should be this slide, so that you know what we have today and some of the high level talking points of the breaker. So we're talking about a 15 kV breaker. Our portfolio is today 15 kV only. Rated up to 2000 amp continuous current and up to 31.5 KA interruption. The bushings are extra creep bushings rated for 125 kV BIO. So I want to point out that a traditional or a typical circuit breaker spec is going to be 15 kV 1200 amp or 15 kV 2000 amp. Our circuit breaker that you see in this picture is rated for 1200 and 2000 amp. The breaker doesn't get physically bigger if we're talking about a 2000 amp versus a 1200 amp. That's a differentiator between ours and some of the competitors out there. We have a compact footprint for 1200 and 2000 amp breakers. The temperature ratings are from minus 40 degrees C to 50 degrees C, and the capacitor switching is rated for 600 amps. Again, this is a magnetically actuated circuit breaker. There's not a lot going on in this low voltage cabinet. Oops. Down here in this low voltage cabinet, what you see is a control board that's responsible for driving the vacuum interrupters open and closed. Otherwise, there's not really anything that needs to be touched or serviced inside of this cabinet. On the next slide, you're going to see how we achieve single phase operation, but you have 3 poles here, A, B, and C, and you have an actuator for each one of them, and you even see visual indicators, one per phase. I'll show you how those work in a moment. Again, the bushings are extra creep standard. You'll notice that on the enclosure itself, there's very few penetrations from a structural standpoint. There's not really many bolts that you can see that keep the breaker together. That was very intentional to help eliminate rust spots, but also eliminate and mitigate moisture ingress and sand ingress. I'll go into details on how we accomplish that. But I also want to point out the high voltage cabinet door is not pictured here because it's a lift off door. You're able to lift it off and remove it easily. It's a lightweight door made out of aluminum with handles, and I'll show you that on another slide. The low voltage panel is a swing door. We can put this on either side of the breaker, left or right, with a 3-point latching system for the handle. The legs in this image are completely, decompressed. They can be extended up to 33 inches. And then we have forklift sleeves here on the front. So this breaker can actually be moved around site using a forklift. Overhead cranes are typical for handling outdoor breakers. So we have lifting eyes up top on the roof that are welded here. But to make things easier, we're allowing customers to use forklifts. We do have thermostatically controlled heaters in the high voltage compartment, some face up, some face down, to keep temperatures regulated. And then the standard warranty for our breaker is 5 years, and that's consistent with the major competitors that we're up against. So again, one slide with primary talking points. I would definitely keep this in your back pocket moving forward. So to get into a little bit more of the design of the breaker, I wanted to put this slide on here because this is basically a cross section of the circuit breaker module. The module is the embedded pole, which is the red part. The embedded pole has the vacuum bottle, which is responsible for interrupting current. And then attached to the bottom of the pole is the magnetic actuator, and this is known as the tray. So together, this embedded pole and the tray with the actuators, they make up the circuit breaker module. And this is the same module that we use in our switch gear, in our indoor switch gear. So took the module, put it in the outdoor breaker, tilted it slightly because we have incoming line and outgoing line connected to the top and bottom of the vacuum bottle. And tilting it gave us the clearances that we needed to meet VIL, just makes a better use of space for the overall cabinet design. So again, this is the vacuum bottle. There's contacts inside of here. These contacts open and close when you have a contingency event, a short circuit event. You're going to have a high amount of current flowing through this vacuum bottle. The protection scheme, the protection relays that the customers are using are gonna recognize that fault event and are gonna issue a trip command to the circuit breaker. That trip command is gonna go to the controller that's in the low voltage cabinet. Once that controller receives the trip command, this magnetic actuator is gonna move in the downward position very quickly, and these vacuum bottle contacts are gonna open. The actuator down here at the bottom moves up and down. It's a linear direct drive motion. There's no crankshaft, there's no rotating components. It is a shaft that physically just moves up and down in between the circular shaped magnetic actuator. And when it moves up and down, it's directly coupled to this push arm, and this push arm moves the bottom contact up and down to open and close the vacuum bottle. So it's a very simple device. Again, there's absolutely no maintenance required on the actuator itself. It's enclosed. I have another image of it that I'll show you in a moment. But absolutely no maintenance required on this actuator. Here's a real life image of the circuit breaker poles up close. If you've been to our factory in Lake Mary, you've seen these poles on the floor. So the pole itself is outsourced. It's the only component that we get outside of the USA. And then once it's in the factory, it's coupled with married with the actuator, which is magnetic, once again, is completely assembled in Lake Mary. And the circuit breaker tray, this is the tray itself with the actuators, one per phase, mounted to it. This whole entire tray assembly module is made in Lake Mary. Coming back to the slide really quick, I just want to show you, these are the position indicators, open and closed. These are IEEE colored, green for open, red for closed. And then there's an operations counter, and this counter changes on the trip counts. Because if you think about it, the circuit breaker is operating, when it operates, it's opening. That's the function of the breaker. So this operation counter operates on the trip. Again, the actuator itself, relatively small, but heavy. If you've been to Lake Mary, you've probably picked one of these up. This is a single coil magnetic actuator. This is the same kind of actuator that has been used in line reclosers for the last 25 or 30 years even. It's a single coil. Think of like a inductive shaped donut, which generates a magnetic field depending on the voltage that's applied to it, either upward or downward. And I'll get into the details of that, but it's compared to another like an ABB or a Siemens magnetic actuator for their outdoor breaker. They use dual coil actuators where you have a top coil and a bottom coil, and each coil is responsible for an upward or a downward motion. Our actuator is one coil that can do both up and down motions depending on the polarity of the voltage that we apply to it. So it's a simplified, consolidated, smaller footprint actuator. Again, it's the same type of actuator that's used in reclosers, and because we're applying this actuator to our circuit breaker, it's small enough and compact enough to do one per phase that allows us to do the single phase trip, single phase close. With the dual coil actuators that ABB and Siemens are using, those things are a lot bigger. You can't put three of them in one breaker to do single phase trip, single phase close. It would be a much bigger breaker. And on an earlier slide, I showed you the size of the outdoor breaker market. 75% of the market size is replacement breakers, replacement infrastructure. Utilities are not trying to replace equipment with bigger equipment. they're always trying to get smaller. So again, so these are the actuators. Again, these are completely made in Florida, along and all of the main components of the breaker are sourced within the US with the exception of the red pole. So that is one of the talking points. I don't want to jump around too much, but you know, I want to keep coming back to that because it is very important a lot of times to the procurement teams at your accounts. I'm not going to get too much into the weeds on this, but I wanted to show you a little animation of how the actuator works. Basically, the orange segment, this is a cross section of that donut shaped coil that I asked you to visualize. And on top of that are permanent magnets. That's what these white things are. So basically, the permanent magnets hold this H-shaped piece that's moving up and down. This is the armature of the breaker. When the breaker is opened or closed, that H-shaped device is held constant. It's either held up or it's held down. And it's held up and down by the permanent magnets that are in the actuator. So in order to change the position or for example, force that armature downward, of a certain polarity signal is sent to the actuator from the capacitors, that allows the magnets to release its hold and allows that actuator to move downward. This centerpiece right here is a spring and acts as like a open assist. So if we need to trip the breaker, that spring decompresses rapidly and allows that armature to get pushed downward because the magnets are no longer holding it up. And then once it's down, it stays down and it stays open until it receives a close command from the controller, at which point the magnetic field that builds up in the inductor pulls the armature upward and then the magnets hold it up. And if that sounds like a mouthful, it's because it probably is. I'm happy to talk with each of you individually about how this breaker works, but just reach out to me at any point in time. There's a lot of language on this slide as well for you to study. So again, I'm not going to spend too much time on this, but this is essentially a recloser actuator that we're looking at. Another close-up picture of the breaker low voltage cabinet. Again, there's not a lot going on in here. What we do see right in the middle is the controller. This is the brains of the circuit breaker. There's a capacitor in this larger rectangle piece right here. And then the smaller piece on the right is a printed circuit board. And the interface to this controller is really as simple as these push buttons that are on the front that allows a local open and close operation. And then there's a ready light. That's what you see right here. And this ready light illuminates blue. So when that ready light is blue, that tells the operator the breaker is ready to go. There's sufficient voltage in the capacitor to drive the actuators open or closed, and the status of the breaker is healthy, all the poles are aligned, everything is kosher and good to go. When that light is blinking, it blinks with different speeds and different I guess frequencies. It's almost like Morse code looking. Depending on if the capacitor is charging, it blinks at a certain rate. If there's an error or an issue with the board, it blinks at a different rate. That is basically the first level troubleshooting mechanism for our customers, depending on the rate that the light is flashing. Otherwise, there's not really a lot that the customers can do with a control board if it's faulty. This is a device that's easily swappable with a new one. So this is basically the one spare component that we recommend customers keep on their shelves. It's a very quick replacement. And then, for example, if the capacitor fails prematurely, which this is a really big concern to a lot of customers, is the health of the capacitor, our recommendation would be to keep an entire assembly on the shelf. If there's an issue, they can replace the assembly in the breaker, take the bad one back to their shop and replace the capacitor in their shop, and then put that whole assembly on the shelf for next time. So it's a really easy cycle to swap out spare parts. The control board itself, this is a simple block diagram. Basically, It consists of a power module that's flexible with the type of control voltage, whether it's 48 volts, 125 volt DC, or 120 AC. There's a controller on board, and then there's a capacitor that's responsible for energizing the actuators. And so once the control board receives a trip or a close command from the customer's Schweitzer relay, for example, because it sensed an overcurrent situation, um, that digital input to the control board is going to allow the capacitor to discharge voltage through the control board through a MOSFET bridge, and that's what dictates the polarity of the voltage that's going to the actuator, and that's what dictates whether it moves up or down or open and closed. So the capacitor, again, it discharges through the control board to the actuator, and then there's a control interface for inputs and outputs, and this is what gets wired to terminal blocks for customer use. And that would be things like, there's a position indicator, there's an operations counter, there's status outputs like capacitor health, but also overall breaker health. So this is how the customer has some visibility into the status of the breaker. Um, when we talk about capacitors, again, customers, whenever I'm having conversations with them, they want to know about the capacitors, especially customers in like super hot climates or super cold climates. I put some information here about the capacitors and the reliability of them. So the capacitors that we're using are high temperature rated capacitors. So they're rated for 221 degrees Fahrenheit for 30 years. That's the spec from the manufacturer. Um, Obviously, that I would consider that best case scenario, right? We're going to have situations where the capacitors don't last that long because there's other variables involved. One of the variables is, how much internal heat is being generated inside that capacitor. In our case, not a lot, because when the capacitor is in steady state, it's about, it draws about 30 milliamps of current to charge the capacitor. It's a very small amount. It doesn't get that hot inside. So the way that we're treating the capacitor and using the capacitor is pretty, I guess I would call it low risk, right? From a application standpoint. We are performing a daily capacitor health check every day. The control board issues, basically it sends a small amount of current to the actuator, and then it measures the dip in voltage in the capacitor, and it measures how long it takes to recharge the capacitor. And the microcontroller on the control board has optimal conditions that have been defined. So the controller knows how fast that capacitor is supposed to recharge. And if it's not recharging in the right time frame or it doesn't have the right recharge profile, that's when we get a digital output from the control board saying that there's an issue with the capacitor. So that should be a pretty big peace of mind for the customers in terms of capacitor monitoring. Um, that's it for the capacitors. All right, I have a couple more slides on the overall construction of the breaker. I want to remind you guys that our team of R&D engineers, they have a tremendous amount of experience designing outdoor circuit breakers. As most of you know, a lot of our team used to work for a major OEM right down the road, and we're very intimately involved with the outdoor circuit breaker at that factory. So we've taken a lot of lessons learned from our past lives and applied them to this circuit breaker. I want to, I'm going to highlight some of those things now, starting with the roof. So we're on the roof of the breaker where we have bushings mounted on the out, that go through the roof from the top outside to the inside, and then we have CTs mounted per bushing, sometimes up to 2 CTs per bushing. That's a lot of weight to put on the roof. And with that much weight, you're bound to have a lot of flexing going on, a lot of forces, especially every time the breaker operates or every time overhead cables are moving in the wind. Just a lot of forces going on the roof of the breaker. So to prevent flexing and bowing of the roof, we welded in crossbars. That's what you see here. And the crossbars actually are responsible for supporting the weight of the CTs and the bushing so that you don't have excess amount of weight on the roof. These are welded into the cabinet. Additionally, the the gasketing system of the roof bushings is a three gasket system where you have the primary gasket that sits underneath the bushing. That's the top one here. And then you have a circular gasket underneath. And then you have an outer, it's a more of it's a aluminum ring. But it basically forces the circular gasket to maintain its rigidity. So you have this like kind of reinforced gasketing system so that the bottom surface of the bushing is always flush with the roof, and you don't have cracks and seams tearing as the overhead cables are moving or twisting in the wind, or when you have the physical bounce of the vacuum bottles when they open and close. You don't have any opportunity for water and sand or whatnot to get into the roof of the circuit breaker. And getting through that roof, I mean, that's a very vulnerable compartment, right? Because that's where the embedded poles are located. You have exposed buswork in that compartment. You really don't want anything in there that's not supposed to be in there. So as much as we can do to keep sand and water out of the high voltage compartment, we will. So we call this a dynamic roof gasketing system because, again, this circular gasket is responsible for creating an upward force on the top gasket at all times. I want to point out that the gasketing, this top blue gasket right here, this would be like the gasket that comes with the bushing from the bushing manufacturer. And other OEMs, that's all they use is that top gasket. They gasket it, they bolt it down, and they're good to go. And then a couple years in service, that gasket starts to tear, and it leans and it over compresses in certain spots, so you end up with small cracks and crevices where stuff can get into the high voltage cabinet. We know that the resolution for, when customers call and say, hey, I got leaking bushing, I need some help, typically they go out to the field and they take the bushing off, put a gasket on, and glue it down to the roof, and then they call it a day. And that doesn't really work because we have dissimilar materials here. The bushing is made out of porcelain, the roof is made out of aluminum. You have different coefficients of thermal expansion. So you have like the temperature swings in the field. Now you have basically a shearing, type of effect that takes place on the gasket, and that just tears the gasket up. It doesn't work. It's not a long-term solution. So we put a lot of thought into how this roof system is designed, and especially when you're talking to customers who are in high contaminant environments, coastal environments, high weather, a lot of rain, they're susceptible to a lot of rain. This is one of the things you want to be talking to them about. And then earlier I showed you that there weren't any visible structural bolts on the cabinet. Our R&D team in Florida, a lot of them are avid fishermen and spend a lot of time on boats, and they replicated some of the design principles from the boating industry to help keep water out of the circuit breaker. And they did that by using um, J channeling, J-shaped um, butt joints. So basically, where two pieces of sheet metal that are adjacent to each other come together, the lips are folded over into J's, and then they're bolted together on the inside. And in between the two pieces of material is another gasket. So we call that a butt joint, and it's reinforced with gasketing. And that's how we've connected the roof to the side sheets and all the side sheets to each other. So again, you won't see any exterior bolts there. You won't see any rusting there, and you won't get any sand and moisture through those areas. I also want to point out the high voltage door is gasketed with a J channel. And so this is a side view. This, like where my mouse is the front of the breaker. And then this J channel is the top of the high voltage cabinet door. And that is basically a shield for the gasket. So now you don't have sun beating down on the gasket. It's not completely exposed to the elements, so it withstands the test of time, and you don't have overcompression um, in any of the locations. So the gasket does its job really well. The high voltage cabinet door, this is the aluminum version with the handles on it. So this is super light. If you guys saw this at IEEE and you were able to pick it up, you know that it's extremely light, easy to handle. Um, it's easy to install it because we have these little hangers that are welded to the front of the cabinet, and then the high voltage door has these just these kind of like rods that fall right into the hanger. The production units, those are unpainted, so they actually serve as a grounding point for the breaker when it's installed. But this is really nice for operators and maintenance crew, because the other doors out there from Siemens and ABB are very heavy and hard to operate. First of all, they don't have handles on the front like this. So you're picking up, I think it's like 40 to 50 pounds, the door. This door, I think is more on the range of like 10 pounds, 11 pounds. Is very light. So it hangs right into the door, into the hanger, and then on the bottom of the door, we have these standoff hex bolts, and that's how you fasten the high voltage door to the breaker. That hex bolt prevents you from over tightening when you're bolting in the cabinet door. It prevents you from over compressing the gasket. So again, that's just another um, design consideration for making sure the gasket's going to do its job over the life of the breaker. The low voltage cabinet door is removable. These are block hinges, and then we have a 3-point stainless steel latching system that's distributed across the top and the bottom. We intentionally angled these inward so that we kind of level out the compression on the gasketing on the top and bottom seams. Um, and then there's a manual trip handle for locking out the breaker in the open position. This is known as the 69 lockout handle. It's padlockable. You move it to the open position, and then you move it a little bit further to the left to lock it out. And then to move it back into the open position, you have to pull a pin lock. So that's designed to prevent any accidental reset of the breaker. You can't close the breaker with this handle, but if it's in the middle open position, it would allow someone to remotely close the breaker. And if you're working on it, you don't want anyone to be able to remotely operate it. So that's why we have a padlock and a pin lock as well to it's kind of a double, um, uh, you know, a, a, a secondary um, device to prevent you from accidentally closing the breaker or allowing someone to close it. Um, For your guys' references, the design tests that we've completed, 2000 amp, again, heat rise test that was performed back in 2023, the mechanical endurance test of 10,000 operations. These are all per IEEE. We are seismic rated, high seismic rated per 693. We have means to adapt our breaker to ABB and Siemens footprints for the 15 kV design, 1200 amp. We've also done IP55 dust and water testing. This is equivalent to a NEMA 4X. And then we also have the IK10 impact resistance, and I'll go through these a little quicker. I'm going to actually breeze through this stuff. Most of you have seen this before, but these are just examples of footprint adapters for ABB and Siemens. And then for IP testing, we had talcum powder blowing around the breaker for 8 hours, 4 different fans. And then at the end of the test, there was virtually no dust inside the breaker compartment. It's extremely impressive. Again, this is equivalent to NEMA 4X. That's the most extreme outdoor rated enclosure that you can get. When I show this to customers, they're usually pretty impressed about this. Similar to water, the water test for IP55, we shoot it from 9 different locations, and the most vulnerable locations of the breaker, the roof, the front, the side. And then at the end of the water test, there was virtually no water inside the breaker. Again, customers are usually very impressed by this FP&L in Florida. They were so impressed, they ordered a breaker from us. So I'll talk about that in a minute too. And then impact resistance, this is the standard test, IK10. That basically you fling a weighted device at the breaker side sheets and at the roof, and make sure there's no denting involved. So we're IK10 rated. And then there's 20 minutes left of this meeting. I want to save time for questions and answers, so I'm going to go through this as efficiently as I can. Capacitor switching. So the breaker, single phase trip, single phase close. There's two different applications that we can talk to customers about. One is cap switching and one is reliability improvements. Capacitor switching, we're talking about closing the breaker on at zero crossing, at 0 volts. And this is to minimize inrush current across the vacuum bottle contacts. We can achieve this using a third-party controller. And this is a test unit. There's voltage sensors attached to the roof of the test unit. There's a Schweitzer relay for protection and control, and then there's a third-party zero cross relay. And this is a VisiMax control. Schweitzer also has their equivalent, but for the case of this test, we used VisiMax. So basically, the blue relay is for protection. That's what's measuring like overcurrent or like under voltage or whatever protection elements the customer is using in their relay. That's a standard device. The zero crossing relay specializes in monitoring when the voltage is zero across each of the phases. And because we have 3 phases that are each individually controlled, we can actually monitor 0 volts on each phase. As you guys know, the current and voltage don't cross zero at the same time across all 3 phases, right? They're 120 degrees apart from each other. So in a traditional breaker, that's a 3 phase operating breaker like ABB or Siemens. If a customer is trying to do zero crossing to minimize transients or inrush current across their vacuum bottle contacts, they're really only doing zero cross on one of the phases. The other 2 phases are 120 degrees out of phase, so they're absolutely not at zero crossing. So you still have, this transient phenomenon happening on 2 of the phases. Our breaker, we can control the opening and closing at zero cross on each phase because they're each individually operated. So that's what this controller is doing. It's monitoring the current voltage on each phase. It's sending a trip command to the controller. The latency that's involved with all these signals for opening and closing, that's accounted for in the configuration of the controller, and it gets dialed in on site and tested, and then we have zero crossing on each phase. And this is a graphic taken at the Kima test lab where we tested this during capacitor switching. So basically, the blue line is zero cross test, and the black line is maximum voltage test. So the blue is basically our breaker with a VisiMax control, and the black line, which is the bottom one rising up, that would be like equivalent to the other phases of a traditional breaker that are not closing at zero cross. And what you see on the bottom graph, the blue line, is the very small amount of inrush current that is generated across the contacts, where the black line is you have a very high spike of transients that eventually, kind of fizzles out. But what we're showing is the black line can have transients as high as 20 kA, and the blue line has transients somewhere around the range of 1 to 4 kA. So again, a traditional breaker, you can do zero cross on one phase, but the other 2 phases are basically going to look like this black line. Whereas on our breaker, where we can close each phase at truly zero crossing, each of the phases are going to see an effect more like the blue line. That's pretty significant for customers who are interested in capacitor switching. I've had conversations with my rep out west, Pacific Power reps, numerous times with a customer down there who has issues repeatedly with transients and failures of circuit breakers for cap switching. I would say for customers that are in like high industrial areas or like farming and agriculture areas that have a lot of inductive loads and have a lot of substations with outdoor capacitor banks, this is something you want to be talking to them about. So either give me a call or your RSMs a call, and we can start that conversation. The other application and value proposition that we have is more on the definitely on like utility, safety, reliability indices. So we talked about reclosers in the beginning that are out on the line. Reclosers have evolved to the point where they can do single phase trip, single phase close, 3 phase trip, 3 phase close. single phase trip, three-phase lockout. There's all the different configurations out there, but the overall intention of the recloser is to basically distinguish between momentary and permanent faults. And if there's a fault event like a tree branch is hitting a line, that recloser is going to go through a cycle of trip close, trip close, trip close to try to clear that fault. A lot of times that the opening and closing of the recloser on the line actually is physical enough that it kind of knocks the tree branch free by the third, close attempt. And then, once the tree branch is gone, the recloser closes it again and there's no fault present, so it stays closed. That's the idea of the recloser is to give the line an opportunity to resolve the fault condition without going into an immediate lockout situation. Because once you go into a lockout situation, your customers don't have power anymore. So how do utilities make money? By keeping their customers energized. And how do the senior managers at utilities make even more money? By improving their reliability metrics at the end of the year. These are actual metrics that are measured and incentivized for utilities. So the number of customers affected by faults, whether it's the number of faults per year or the number of minutes per year, those are very important metrics that are tracked and monitored by utilities. And a lot of times rate cases are also tied to them. So when utilities want to go to the PUC asking for money, they have to show an improvement in reliability scores a lot of times before the PUC is going to approve a rate case. So how can you improve reliability scores? By deploying reclosers. How can you improve reliability scores even more? By performing reclosing at the substation. So we say that very optimistically, right? But the reality is this is a very difficult application for utilities to implement, especially on greenfield substations. Um, it's not as easy as it sounds, and we recognize that. There's utilities are still learning how to use reclosers in the outside the fence and how to coordinate all their devices outside the fence. So bringing it all the way into the fence is a paradigm shift that is we can expect it to take a few more years. What I would say is that, when you're talking to customers about greenfield substations, especially substations that are serving high population density areas, substations that are going to be dedicated to new housing developments, for example, those are substations that are going to have a lot of single phase loads where customers might be more inclined to perform single phase trip, single phase lockout, or even single phase trip, three-phase lockout all the way back to the substation. It's where there's single phase loads where they're going to want to do that. They're not going to want to do this on three-phase loads. Commercial, heavy industrial, where you have a lot of three-phase loads, you're not going to be doing single phase trip, single phase close. So it's really going to be high population areas, new developments, and it could be pitched as an easy button for SAIDI and SAIFI improvements, because SAIDI and SAIFI are functions of number of customers. So when you have a lot of customers smashed into one small area, and you can do single phase trip, single phase close all the way back to the substation, you're going to have an immediate significant impact on SAIDI and SAIFI. So again, we know that we pitched this reliability improvement application since the beginning of our outdoor breaker. And I know a lot of you have come to us saying, look, it's not that easy. It's not that easy. We recognize it. But I would say there is still a case to be made when you're talking to customers about greenfield, new substations that are dedicated to serving new developments, housing developments. We can talk more about this on the side if you have more questions. But let's just to visualize what we're talking about. This is a typical distribution system. So up here in the top, this is the substation. Got a transformer, distribution transformer, and then these rectangles are the circuit breakers. And then the circuit breaker has three phases coming out of it. A lot of times on developed networks, you're going to have a recloser somewhere outside the fence that's going to have radial lines, one coming out of each recloser. Those reclosers are great. They're doing their job downstream. But what about the segment of line between the circuit breaker and the recloser? You still have loads in between there, but you don't have any type of way to distinguish between momentary and permanent faults on those lines. So if you have a fault event on one line down here, which is a tree branch, a lot of times that circuit breaker is going to go into three-phase lockout. Not always, but some customers are in effect doing three-phase reclosing out of the substation, but you're still interrupting all three phases. Our breaker can interrupt just one phase, right? So if you have a tree branch hitting one phase, the other two phases are going to be fully energized. They're not going to see any flashing lights, any on off of the lights. Only one phase is going to see that. To look at it a little bit more from an animation standpoint, again, so like the tree, and I'm using a tree as just a general example, tree hits the line in a typical breaker, all three phases are going to open, close, open, close, open, close, and then go into three-phase lockout if it's a permanent fault. But with the OD3Mag breaker, if that tree branch hits one line, only one line is going to open and close while the other two lines stay energized. So you're you're not affecting any of these guys from a momentary standpoint. And then if it's a permanent fault, if that tree fell over, you can actually just lock out one of the lines completely and the other two stay fully energized. So now again, you have a huge impact on the number of customers that are being affected. In this case, if we had 100 customers per line, now you're only affecting 300 customers instead of 900. So that's a 66% improvement on safety right there. We got 9 minutes left in this meeting. I want to just point out a couple of Pioneer customers that have purchased the outdoor breaker from us. These are customers that have received their breakers, not necessarily installed yet, so more to come on these. At Florida Power and Light, Salem Electric, and Huntersville. So we do have some breakers out there in the hands of customers. I know Salem Electric, this is one of the customers I work with, had really good things to say about receiving our breaker and about the build quality, and they've already acted as a reference for some other utilities. They haven't even installed it yet. We're going to be there for the installation. We're going to give them full support. That's our commitment to getting this product out on the market and making sure things are going well. So, please, we are very serious about the future of this product, and we really are going to depend on you guys to help us sell some breakers. So how you can do that is by setting up lunch and learns with your RSMs. We can schedule demo meetings. We have at least one demo breaker in Lake Mary that we can ship out. I know we had talked about a demo program on a truck bed that is on hold right now. I don't have a lot of updates on that at this point in time, but what I do have is a breaker sitting in Lake Mary that if we have, a legitimate opportunity to send to a customer, we'll do that. So again, send us your specs. The more quoting we can do, the better. We're finding that we are consistently competitive from a price standpoint. Our lead time is about 24 to 26 weeks out of Lake Mary. And I know you guys are anxious about the 2738 kV designs. I can tell you that both of those are underway. The 27 kV is essentially going to be the same breaker. The pole is already rated 27 kV, so it's a matter of meeting the BIL ratings, which are 150 kV BIL at that level. So we're taking some measures to change out the bushings and make sure we have the dielectric distances that we need between phases. We're basically adapting our 15 kV breaker to 27 kV. The 38 kV breaker is a full-on redesign of the circuit breaker. Both projects are being looked at by R&D, are being actively worked on, and the plan is to take the 27 kV and the 38 kV to KEMA at the same time, and that's going to be overseas. I think it's in Amsterdam, actually. So that's the game plan. That KEMA test date is not on the calendar yet, but it's expected to be in early 2025. So we're thinking like mid 2025. We'll have at least a 27 kV, maybe a 38 kV commercially available. So appreciate your guys' patience. It is a process, but that is the direction we're headed, and we have a great product available today. So please let us know what we can do to support you guys and get the breaker out there. So that's my last slide, and we have 5 minutes left for questions. So I'll go ahead and open it up. I'm not sure, Robin or Jason, if you saw any hands getting raised, but go ahead and fire away.
We have a few questions from the chat here, Erin, and if you do have any additional questions, please feel free to add them in the chat, or if you just want to raise your hand, we'll take you off mute so you can ask your question out loud. One question from Lisa was, does the spring lose tension over time, which would cause the breaker to open more slowly?
Our spring, the little spring that I showed in the graphic. Is that the spring you're talking about, Lisa? Or are you talking about in a traditional spring mech breaker? I'll answer both. So in the magnetic actuator, I showed you guys that there's this little internal spring. Just get to it really quick. Right here.
Lisa says the spring in the graphic.
Yeah, right here, there's a spring. No, that's not gonna introduce sag, and it's not gonna lose K-force similar to the large springs that you see in a traditional breaker. This is a open assist. When most of the time the breaker is closed, right? Because there's current flowing through the vacuum bottles. The system's energized, the breaker's closed, so that spring is compressed most of the time. When we see it operate is when the armature moves down and that spring decompresses, which is its natural response, and it flings the armature downward. That's happening so fast. It's faster than a 3-cycle time frame that the breaker's rated for. In 10,000 operations, we didn't see any significant decrease in breaker opening time. And if that answers your question, it's not gonna have the same type of effect as one of those major huge springs in a spring mech where you need it to compress and decompress quickly. I hope that answers your question.
Yes, she says thank you. Doug asks, what is the effect of the conductors that makes true zero crossing trip on every phase desirable?
Can you say that again?
What does the effect on the conductors that makes the true zero crossing trip on every phase desirable? And I'll see if I can get.
What is the effect of the conductors?
Yeah, Doug, do you want to ask your question?
Was that Doug Verhill or Doug Martell?
Thackeray.
Oh,
actually.
Thackeray, sorry.
There's many Dougs.
Maybe he stepped away. I'll call him after this and get clarification, and then I'll send out a response to the question with the slides for everybody. Were there any other questions, Robin?
That was it from the chat. Does anybody have a question? If they could raise their hand and I could take you off mute.
Oh, Lisa's got another question.
Yep, Lisa,
Yeah.
yep.
So you said FPL bought one breaker?
FPL.
Yeah, the FPL, right. Have they installed it yet? Do you know?
Jason, do you know?
No, we're working through them, but we hope to have it. It's in production. We're just hopefully have it sent out later this year, first of next year.
FPL was especially interested in the environmental and the IP testing of the breaker. As you can imagine, they're exposed to a lot of hurricane force winds and have very stringent rain test requirements. So they came to our factory a couple of times. We were able to demonstrate the water mitigation features of the breaker, and they committed to buying one. So really happy to see this one get installed. Any other questions?
I think Doug is still looking for an answer. If you can take him off mute.
Yeah, he's off mute. Doug, you just need to take yourself off mute and you can ask your question.
If not, I'll send you Aaron his information. You can give him a ring.
Okay. All right, guys. That wraps up this 1 hour session. Again, if there's anything we can do to help you, please reach out to your RSM, reach out to myself for any technical support. And looking forward to selling some breakers with you guys. Have a safe day and talk to y'all soon.